WASSCE June 2024 questions 1 to 5. So let's start with number 1. Now, multiply 3.4. So let me create a space here. Multiply 3.4 times 10 to the power of minus 5 with 7.1 times 10 to the power of 8. So what we can do is that we can keep these two first. Okay, you are going against time. You are highlighting the exam against time. So when you do this, you have to look at the time. So we have to be quick. Now let's focus on this one, 3.4 and 7.1. We multiply them together. So we have 3.4 times 7.1. 4 times 7 is 28. So we have 8 here, bring 2. 3 times 7 is 21 plus 2, that is 23. Okay, and then for 1 times 4 is 4. 1 times 3 is 3. So add everything together. This is 4, 11, 4, 2. So right now we have 2, 4, 1, 4. However, remember we have how many decimal places in total? We have 1, 2, or how many numbers are after the decimal point? We have 2 numbers. So we have to account for that by saying 1, 2. This becomes 24.14. Now remember that we still have this and this. So let's combine them. We have 10 to the power of minus 5 times 10 to the power of 8. If you apply your law of indices, we can simply add the powers together. That becomes 10 to the power of minus 5 plus 8, which gives us 10 to the power of 3. Now we can bring this over here. We can now have 24.14 times 10 to the power of 3. Now we have to express it in standard form, meaning that we have to move the decimal place here. Okay, only one number can be in front of the decimal place if we are moving it to standard form. Now, if you move it towards the left, okay, this now becomes 2.414 times 10 times 10 to the power of 3, okay, which is something as 10 to the power of 4. Now we can add these powers together. It becomes 2.414 times 10 to the power of 4. So this will be your answer. Okay, so whenever you are expressing in standard form, your decimal place, there only has to be one number. Okay, from 1 to 9, there only has to be one number in front of the decimal place, or in front of the decimal point, or rather. Okay, writing 24.14 times 10 to the power 3 is not standard form. You have to move the decimal point. And there just has to be one number in front of it, or let me say to the left of the decimal point. Now, because you moved it towards the left, you now have 2.414 times 10. Okay, because you're moving towards the left. Then consider your 10 to the power of 3 before. Okay, then you can now add them together. This becomes 2.414 times 10 to the power of 4. All right. Okay, so that will be the answer. So if you have the past questions, you can check the options. I'm not giving the options so that you can see that we don't want to depend on them. We just want to solve it, and then you can cross-check. Next question. Given that P, okay, such that P is between 1 and 20, so P is between 1 to 20. Well, what does that mean? You can see there's no less than or equal. It's simply less than, less than. So it means that P is between 1 to 20. So you have numbers like 2, 3, 4, up until 19. Okay, so the values of P to be, and P is an integer, so it's from 2 to 19. Now we have R, okay, such that R is a multiple of 4 from 0 to 25. So both 0 and 25 are included. However, 0 and 25 are not multiples of 4, so we don't really need to add them. But what are the multiples of 4 from 0 to 25? Well, we'll always start with 4. 4, 8, 12, 16, 20, 24. So those are the multiples of 4 from 0 to 25. Now they said find P intersection R. So it means that we're looking for numbers, or or let me use the word elements, that are both in P and R. Okay. So if I were to let me create a space down here. Sorry. Yes. Let me create a space down here for, so we said P are numbers from 2 to 19. And then for R, we have 4, 8, 12, 16, 20, and 24. So we're looking for numbers that will be in, in both P and R. So obviously, 4 is between 2 and 19. 8 also falls within that range. 12, yes. 16, yes. 20, no, because 20 is greater than 19. Okay, so the numbers that will fall within this range will be 4, 8, 12, 16. All right, so this will be your answer. So it means that P intersection R, we have 4, 8, 12, 16. So when you say intersection, you're looking for the numbers that are in both, okay, that are present in both sets. Okay, numbers that are present in both sets. 20 is in R, but it's not in P. 24 is in R, but it's not in P. 2 is in P, but it's not in R. So we're looking for elements that are present in both sets. All right, both sets. That's what it means of intersection. If you, let's say, if the question was P union R, we're simply joining everything together. Okay, we're going to just add all the elements together. All right, so that will be your answer. This will be your answer. 4, 8, 12, 16. All right, now we have this. The first term of an arithmetic progression. So when you're writing questions like this is an objective question. Okay, you don't have to write too much. You just have to know your values, work with speed. All right. So first of all, on AP, so A1 is 2. Last term, we don't know what's the last, like, is it the fifth term or seventh term? We just write AN is 29 because that's our last term. If the common difference is D is 3, how many terms are in the AP? So that's what we're looking for, N. Okay, how many terms are in the AP? We're looking for this N that is here. You know that the formula for end term, which is our end term here, end term. So AN is equal to A1 plus N minus 1D. We know our AN, our N term is 29. Our A1 is 2. Our common difference is 3. So we're looking for our N. All right. So this now becomes okay. Sorry. So this now becomes 29 is equal to 2 plus N minus 1D. N minus 1 times 3. Okay, so now I can move this to the other side, to the left hand side. It now becomes minus 2. Remember, when you move numbers to either side of, or to the other side of the equal to sign, the sign is going to change. So it becomes 29 minus 2 is equal to, I won't expand this yet. It's equal to 3n minus 1. Okay, 29 minus 2 is 27. 27 equals 3. And this is why I chose not to expand it, because I can easily divide both sides by 3. This now gives me 9 equals n minus 1, because 27 divided by 3 is 9, and then 3 cancels out 3. We're left with n minus 1 equals 9. So I think you know what the answer is. So you can either just say, you can move the minus 1 to the left hand side. This becomes 9 plus 1 equals n, and that's 10. So n equals, so you can ask yourself, what number do I have to subtract 1 from to get 9? It's 10. So your n is 10. So it means that this is the going back to the question. All right, so going back to the question, how many terms are in the AP? And it's 10, so there are 10 terms. Your A1 is 3, or is 2, sorry, 2. Common difference is 3, and your 10th term is 29. Okay, 10th term is 29. And here's another tip. If you notice that the common difference is an odd number, yeah? So look at it. The first term is 2. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. What does that, like, what do you notice here? The odd terms like 1, the odd terms like 1, 3, let's say the next term, this will be 14, and 5. The odd terms are even numbers. Why the even terms? Okay, like even like the second term, the fourth term are odd numbers. So like since we said that 29 is a 10 term, it makes sense because the even terms are odd numbers. So if, for example, we got our n as 9, for example, okay, we'll start to think if we made a mistake. Like so these are ways you can check if you know to confirm your answer. It's not always the case, but in this question, this is the case because you started with an even number, and then your common difference are odd number. So your common difference is an odd number. So you have alternating even and odd numbers. All right. So let's go to question number 4. Now express this in index form. Now, so let's deal with this first. This is when you add logs together. Log a x, okay, or you say log x base a. That's how you say it. This is how you say. You can say it like this: log x base a, because this is your base and this is your actual value, your log x. Okay, so log x base a plus log y base a. So both of them are base a. So how do you can you combine them? Yes, if you consider the laws of logarithms, okay, because they share the same base, you can actually, so this now becomes log x base a plus log y base a. Can now combine them and say log x dot y. Let me use dot x times y base a, because when you add logs together, you can combine them by just simply multiplying the values here, and keep the base a. Okay, so let me give an example. Okay, just a rough example. Let's say I have log um log 27 base 3 plus log 9 base 3. Just give it an example. So log 27 base 3 is 3. Log 9 base 3 is 2. That gives us 3 plus 2. It gives us 5. If I were to multiply them at this how, this would be log 27 times 9 base 3. 27 times 9, but that would give us 243. Yeah, that would be log 3, log 243 base 3. And what is that? That also gives us 5. So it means that this you can write this as this. You can multiply these values together. So that is what I did. Okay, so I'm just giving an example to show you that it works. So now we have log a and log x dot y, or log x times y, or log xy base a is equal to 3. Now we can change this to index form. We move the a to the other side to change it to index form. You move the base. Okay, you raise the base to the power of 3. That becomes x y equals a to the power of 3, and this is your answer in index form. Or x times y is equal to a to the power of 3. So this will be your answer in index form. Okay, so I think the topic here is more about, is based on, I think, of the laws of logarithm, laws of log, and then index form. So that is where this topic is, or this question is based on. It's based on laws of logarithm, and then we're expressing it in index form. So your answer will be xy is equal to a to the power of 3. All right, and then for the last question, simplify. So there are two ways you can actually apply, what we call this, you know, the square of a sum and square of difference. Or you can simply expand it the way you want. Okay. So now we have know that a minus b squared is equal to a squared minus 2ab plus b squared. So if we apply that same thing where we have 2p minus q all squared, that now becomes 2p squared. Okay, so you take the 2p to the jump together, 2p squared minus 2 2p q plus q squared. This now becomes this will be 4p squared. 2 times 2 is 4, so it's minus 4pq, okay, plus q squared. So this just to be, if you want to be quick, you just have to know that what do you call it, this the square of a difference is just going to give you this, okay. And then for the p plus q or p plus q all squared, we know that uh, a plus b all squared is going to give us a squared plus 2ab plus b squared. Okay, if you want to expand it your way, if you want to expand it your method, it's fine. I just this is just a faster way, you know. So we have p plus q. We apply the same thing all squared. It becomes p squared plus 2pq plus q squared. So now we can there's a subtraction sign here. So now we can subtract them together. So this becomes, so I'll put a bracket to avoid any mistakes. So it's always good to do that. So now we have 4p squared minus 4pq plus q squared minus p squared plus 2pq plus q squared. Okay. So now we open the bracket. So this becomes 4p squared minus 4pq plus q squared minus p squared minus 2pq minus q squared, because this minus is affecting everything here. Okay, so this plus minus times plus becomes minus, minus times plus also becomes minus. So let's do the subtraction. I'll be quick about it. For 4p squared minus p squared, that becomes 3p squared. Okay, minus 4pq minus 6pq, that will be, sorry, minus 4pq minus 2pq, that will be minus 6pq. I'm sorry, I'm already getting ahead of myself. And then q square minus q square. So the answer will be 3p square minus 6pq. Okay, this say we should factorize. I highly doubt. You can factorize this if you want, but what is the need? Simplify. This is fine. Or if you have to factorize, like since I didn't put the options there, depending on how the options will be, you can decide to say, okay, I'll factorize 3p here. Now this becomes p minus 2q. This answer is fine, but if they wanted you to factorize, this would also be the answer there. So that's why I don't want to, I want to do everything. I want you to consider all your options, like when you're doing things like that. That's why I chose not to put options like, okay, so this answer is fine. You can have it like this, or if they wanted you to factorize, then it's be like this. Okay, so those are the first 5 questions. So these questions, this was based on expansion. This is laws of logarithm. This is arithmetic progression sets, and lastly just numbers, numbers. All right, so we'll continue from there. We'll go to 6 to 10, 11 to 15, and all that. Just, if you have any questions, let me know in the comments. Just reach out to me. I'll be available to explain more. Thank you.